Hello, everyone, and welcome back to another episode of Teach, Sleep, Repeat. My name is Dylan.
And my name's Hayden.
And this week we're going to be diving into our favourite subject. You know what it is. It's math.
We're going to be talking fluency, reasoning, and problem solving, defining them, and also going over some of the misconceptions around them.
We'll take a look at how to structure a really quality maths lesson and sequence of learning, as well as being able to use schemes without them becoming limiting and frustrating.
And make sure you stick around because we'll be giving some sneak peek information about what we've been up to behind the scenes in the maths world.
Oh, how exciting. Let's go. All right, so I think before we dive into this, we should just give some context. Listeners will know how much we love maths. They will know how involved we are with maths in our whole career.
Will they?
However, I just want to make this really clear for anyone maybe who's watching or listening for the first time or isn't quite sure about why we feel like we can almost be the experts here talking about maths. Our careers, I think it's defined by maths. I loved being a primary school teacher because you could teach all the subjects, but my passion and what I was really interested in and what I thought I did really well was teach maths. Same for you.
I was a primary maths teacher.
Yeah.
And I had to teach some other subjects as well. That's the way I see it. My family literally asked, like they got, when I was just throughout my career, they're like, oh yeah, how's the old maths teaching? I was like, do know I do actually teach other stuff as well, even though I only talk about maths. I do also teach English and geography, everything else.
Yeah. And I think when we trained at university, our main focus was maths as well. Like we literally had maths specialist input. From Gina Donaldson. Gina, I don't know if you're listening, Gina Donaldson, but you are genuinely the reason why I felt like I could become an expert in maths, and I felt like I could pass it on to the children because she inspired me. She was unbelievable as a tutor. It was at Canterbury Christchurch University, 10 out of 10. And having done her course, I felt equipped almost straight away because, again, we trained in 2014, 2015, around the time of this new curriculum. So we were in this really odd position where in university, we were being taught how to teach maths in this almost new mastery way, but embedded in the new curriculum from the start. So when we went into school, we almost had a head start in that respect, I think.
Big time.
And it was like, no, this is just how you teach maths. And this whole idea of, new maths, different to what I did before. We had none of that really, because it was just, that's how we were learned.
And having now taught for 10 years, I can't believe how important that was. I also had Gina, so big up. Transformational in terms of changing my, just eradicating my misconceptions about maths and how I very much thought of it's just, you see it online all the time now, people being like, don't teach the kids multiple methods, just do this one way, it always works, and then they can get the questions right in the test. There are so many reasons I could argue against that, and we'll go into it when we talk about fluency and all the other bits, but Gina really just immediately from day one was like, yep, here is a more holistic way to think about how people learn maths really well. And it just shaped my maths teaching.
And this is why it's better. And this is why it's
exactly
good. And then when we went into school, very quickly you became maths lead of the school where I worked. I remember you becoming maths lead and I was on the hub, the team, but you were the leader for that. And then when we ended up in our school that we worked in together, just before, at the end of our teaching journey, we both led maths together. We kind of co-led it. You were my assistant to the maths lead. I was the maths lead. So you were very much just kind of below me. But we've led maths in school for years and years and years and years. And one of my big passions, and this is why we're doing this episode, is to just help other teachers understand maybe some of the terminology, fluency, reasoning, problem solving, what it means, what it might look like in a lesson, why it's important, which ones we should weight more heavily, what it might look like in a classroom, and importantly, what the misconceptions are as to what good maths teaching actually might look like, which I think embedded in a lot of schools now for reasons where they want to help their children as much as possible and want to meet the national curriculum aims. They're actually doing things that I think are potentially bad practice when it comes to maths in general. So hopefully we can flesh some bits out, talk about what different words mean literally in the curriculum, and then dive into what a good lesson might look like, how we might structure things, and basically let our passion shine through.
Nerd out, that's what they're saying, because we love maths and we could just talk about this for hours.
Precisely that. So let's start off. I think it's important that everything we do is rooted in the national curriculum aims. So I'm going to talk about the aims specifically for the maths curriculum now in primary school. And it's split up into 3 chunks. And these 3 chunks are things people will have heard of at some point in their training or just in their delivery of maths lessons in primary school. And that is fluency, reasoning, and problem solving. So let's read them through now. This is from the national curriculum. The national curriculum for mathematics aims to ensure that all pupils, and that's really important, all pupils, we'll come back to that. Number 1, become fluent in the fundamentals of mathematics, including through varied and frequent practice with increasingly complex problems over time, so that pupils develop a conceptual understanding and the ability to recall and apply knowledge rapidly and accurately. It goes on to then say, number 2, to reason mathematically by following a line of inquiry, conjecturing relationships and generalizations, and developing an argument, justification, or proof using mathematical language. And thirdly, can problem solve by applying their mathematics to a variety of routine and non-routine problems with increasing sophistication, including breaking down problems into a series of smaller, simpler steps and persevering in seeking solutions.
Excellent. Shall we dive in then? Should we break these down? Should we just go into fluency now and really just talk about what fluency is? Again, some of the misconceptions and just, our top tips and what it looks like in a lesson, how to embed it into lessons.
Yeah, because when people say fluency, I think you can sometimes simplify it in your head as, do you know your times tables?
Yeah.
Can you add up? Can you subtract? And I think that's part of fluency. I think that's really important. And one thing we'll be referencing throughout this, I think it's a fantastic blog on Third Space Learning by Neil Almond. He did a whole blog about reasoning, problem solving, and fluency. And a lot of what he says resonates with the way I think we think about maths as well. So we'll be referencing that too. We'll leave a link down in the description to that whole blog. If you wanted to read, I would recommend it. But fluency, to me, it's being able to understand mathematical facts and know them quickly, to understand concepts and know them quickly, and mathematical language and to understand what they mean. And for me, being fluent in something means practicing doing the maths, understanding the words or knowing the concepts so it becomes second nature. And that's when you become fluent. So fluency is something you should be working towards becoming. Are you fluent in addition and subtraction at the year 4 level? Yes or no?
Yeah.
The answer for most children will be no, and we're working towards becoming fluent. So when we say what does fluency look like, or varied fluency, or mixed fluency in a maths lesson, it's ensuring that children are exposed to ability to practice things and not be scared of practicing things over and over, because you need to be able to do the maths. Do they understand the language being used in that topic? And I would say being exposed to doing the maths, but in many different representations.
So I think a lot of people would say, and maybe you can clarify a bit more about with this, a lot of people would say that fluency equals arithmetic. So just going a bit further from you said fluency might be just times tables, but I think you can expand that to a genuine misconception, which is that it's just arithmetic. So do you think when it comes down to things like Key Stage 1, 2 arithmetic papers, or just generally arithmetic papers in your year group, do you think that embodies entirely fluency? Because ultimately it's all the methods you need to know to do maths.
So what I would say to people is arithmetic is part of fluency. It's one string to the bow. It's really, really, really important. You could even say it's potentially the most important part of fluency, in my opinion. And I think we could argue that, and I think you might be right to say that. I think it's the actually being able to literally manipulate number using the 4 operations is the most fundamentally important part of maths. And then what I worry about sometimes, and what I see in schools, is it's kind of brushed aside or rushed through or thought, that's important, but we need to reason and problem solve. No. You literally cannot reason and problem solve if you can't do the maths. So let's talk about arithmetic in particular. I think that is vital. And it very much links to the kind of thing we're working on now. We're building platform to help teachers and children become fluent, and specifically to begin with, get better at arithmetic.
Another sneaky hint.
Another sneaky hint is what's going up.
But it's true, because I kind of want to talk about both, because we're obviously extremely passionate about this. And I genuinely think, just backing up what you're saying, I think arithmetic, particularly as part of fluency in general, I would say, is absolutely the most fundamentally important part of maths, genuinely. And I do feel like, because we can also say the end goal of maths is problem solving, I do think we conflate the importance levels of them. It's like, the end goal is problem solving, but fluency is the most important bit, because you can't do it without it. It's literally the foundation of the house you're building. You have to get it right. There's way more to it. You know, but if you think about the classic pyramid example, I think even Third Space Learning has a couple of different examples of that. It kind of is, crudely, it's the massive bit at the bottom, fluency, and that involves, majority of that is arithmetic. We've got to get it right.
And I think that's really important. And that's the link. We're going to be drawing these links throughout this, and you'll see why. We'll maybe come back to it once we've defined, reasoning and problem solving, why actually this is the most important part. Fluency is the most fundamental part of, if you're teaching primary mathematics properly, you have to get this right. And if you are glazing over it to go through more quickly to reasoning and problem solving without becoming secure in your fluency, you're doing your children a disservice, because who can problem solve if they can't, once they've figured out what to do, actually do it. It's the most important thing.
Yeah.
And just going back to what you said about fluency, and we said arithmetic's part of fluency. So I can imagine some people might be out there thinking, well, what do you mean part? What's the rest? For example, think of your part whole models. Think of schemes like White Rose Learning, White Rose Maths that a lot of schools use out there, and what questions might look like 1, 2, 3, and 4. And I can imagine sometimes as a teacher, I've known teachers who become frustrated that, oh, they've only done 4 questions like this, then suddenly they've got a part whole model, then suddenly they've got a bar model, then suddenly they've got an inverse operation, and suddenly the presentation looks different and the missing answer box is in a different place.
Yeah.
That's down to you as a teacher. I think good schemes give lots of opportunities for fluency like this.
Yep.
But you as a teacher need to understand what fluency is and why it's important, and almost hierarchically move through fluency in a way that's still sensible. Because I think sometimes with fluency, people hear, okay, I kind of get what you're saying now, Dylan. Fluency is this like ability to have lots of different representations of questions and being able to apply, maybe let's just talk about addition, to lots of different ways and be like, oh, okay, even though this is a part whole model, I'm adding. Even though this is maybe a bar model, I'm adding. This might be just literally written out as arithmetic, but I'm adding. That is fluency, but it doesn't mean you have to just randomly do them off the bat.
Yeah.
Big part of fluency is, can you do the maths in the first place? Can you literally add 2 numbers together? Okay. Then we can expand it to some ideas of maybe, okay, look, maybe not just arithmetic now, but it might be shown in a different way.
Yeah.
And then there's even another step of fluency, which is, do you know how many sides a square has?
Exactly.
That's not reasoning or problem solving. Do you know how many centimeters are in a meter? This is when we talk about the known facts, the things you just have to know. You just have to know the definition of some words. You need to know what perimeter means. That's not reasoning and problem solving.
It's not arithmetic either.
Exactly. It's not arithmetic, but it is fluency, and it comes under that umbrella. And this is why fluency is vital. If you don't know what words mean, mathematical vocabulary, if you can't do the maths, and if you don't understand the concept, you can't do maths.
Yeah, exactly.
I can't get across enough how I feel like fluency is maths. And the reason people push back and they say, well, no, problem solving is maths. Correct. It overlaps. We can't see it as separate things that we just do separately. It's one in the same. And the way the aims of the curriculum are written down, and the way sometimes schemes of work present things, and the way sometimes we're taught how to teach a maths lesson, I feel like fluency just gets lumped in as like, yeah, you do that for a bit, and then we do some reasoning and problem solving. What I'm trying to get here is, with the definition of fluency, is it is fundamentally what a maths lesson should be. And then you work towards, with your reasoning and problem solving, which we'll come on to, moving through
the flow chart in my head when I'm thinking about the 3 elements of maths, fluency, reasoning, problem solving, is I think to myself, are the kids fluent in the maths that I'm thinking of right now? Yes or no?
Right.
If the answer is yes, then I'll start thinking, oh, cool. I wonder if I can expose them to some opportunities to solve some problems now where they can use their reasoning skills and they can apply this fluency. And if the answer is no, my genuine thought is either, okay, cool, can I do some more fluency with them until they become fluent? Can I do, maybe it is just straight arithmetic if they're really, really struggling even with the method at this point. Maybe it's just they're struggling with different representations. They've not been exposed enough yet to different ways of seeing. They're really good at the method. They're just not very good at recognizing, oh, that's when I need to use that method. Definitions, equally stuff like that that's outside of arithmetic. But even still, if the answer is no, I might still think, I would like to expose my children to a bit of problem solving, but I might use something they're fluent in something else, which we'll come to, I guess, when we talk more about problem solving. But the fundamental part of what I'm saying here is I always think to myself, are they fluent or are they not? That's my first thought. It's not just, does the lesson structure tell me I need to be doing some reasoning on this objective today and some problem solving? That's not the way to think about maths, because they need to be fluent. That's the point. If they're not fluent, don't do it.
It's such a good point. And let's move on to reasoning now. So we talked about fluency. Reasoning is to me really bizarre and unique.
Hardest one to define. Right?
I think so, and I think I can kind of define it, but I feel like the old-fashioned way of thinking of these as 3 pillars of maths, I don't think is helpful. I feel like there's a very old-fashioned way where you think of, you've got your fluency, then you've got your reasoning questions, then you've got your problem-solving questions. And what I'm trying to do as we go through this, I think we're trying to just eradicate that thought process. Don't think of them as separate pots. Because to me, reasoning is the ultimate version of, you reason all of the time. So reasoning, again, let's think about what reasoning actually is. To define it, I'm going to be taking from Neil Ormond in this blog, because I think the way he puts things down on paper is a really, really clear way of thinking about it. Reasoning and maths is the process of applying logical thinking to a situation to derive the correct problem-solving strategy for a given question. Put more simply, mathematical reasoning is the bridge between fluency and problem solving. It allows pupils to use the former accurately to carry out the latter.
Right.
And I think that's such a nice way of thinking about it is you can't just think about reasoning as, have I done reasoning questions today? Reasoning is the art of thinking. It's the art of actually doing maths. And I'd argue there's an overlap with fluency. Clearly, there's an overlap here with problem solving because we have to reason and think about what we're going to pick to solve a problem. We'll come on to problem solving.
Yeah.
But also, I think with fluency, I think picking efficient methods, that's reasoning.
Yeah.
Thinking, if I had to explain to someone why this method is more efficient than that method, that is definitely reasoning. And it's the kind of thing I'd be doing during my fluency part of my lesson. I wouldn't be thinking, oh, Christ, no, I can't possibly reason now. I'm in my fluency part of my lesson. We're just practicing. No.
Yeah.
Reasoning is everything. And I think quality reasoning happens to all children all of the time, no matter what they're doing. Because at any point as a teacher, you can be asking questions like, why are you doing that? What's the benefit of doing that? Why have you exchanged there in that question?
Yeah.
Well, that's weird because on the other table, they did this method. Do you think that's better or worse? They're still doing fluency.
Why have you used inverse here?
Exactly.
You know, even just that, like you said, I agree, by the way. I think reasoning is very much, it's the glue.
Yeah.
And it ranges all the way from fluency all the way into problem solving.
Yeah.
I can think of the most basic version of this where you could just about say, yeah, actually, there's a bit of reasoning going on here, which is, right, you've taught the kids the arithmetic of adding two numbers. They know the method. They know how to line it up and do the addition. And when something says this, add this, they can do it, right? And then you present them, this is all within fluency still, based on all these definitions. When you then present them an inverse question where it's blank, take away a number equals a number, and you know as a teacher, they've actually, even though it says the subtraction symbol in this question, they've got to add those two parts together to get back to that total. They're still using the exact same method you taught them. There's nothing different about the method and the arithmetic that they've got to use to solve this. But technically, they've got to think just a little bit more than the last ones of, wait, am I supposed to be subtracting here? Or, wait, it's laid out this way, which means I need to use inverse, which means I'm still using addition. Great, I can do that. That to me is like the smallest increment where I can think of where it's like, you could say there's a bit of reasoning happening there now, but that's very much fluency. So that kind of just backs up this idea that reasoning really is the glue. It happens all the way through fluency. It happens all the way up to just complete problem solving. Yeah. It's kind of everywhere. It's like you said, it's not really like a separate thing, isolated. You've got your fluency, then you've got this thing explicitly called reasoning, and then you've got this thing explicitly called problem solving. It doesn't work like that. I think that the reason why I think this has happened and developed over time is because I do think there are some questions which are, you can't refute that it's a reasoning question. They do exist. Like they can exist in terms of explaining your method. You've seen these questions a million times in all these schemes where it says, think about Tiny from White Rose Maths, right? Tiny's done this. Where's he gone wrong? Yeah. That's fun. That is reasoning. It says, explain your reasoning.
Yeah, explain your reasoning. It is literally reasoning. Yeah. But again, you literally can't do that reasoning unless you understand the process.
Yeah, you've got to be fluent in the thing he's talking about.
Exactly. How can you possibly do that? And then that's when good teaching in the moment of doing fluency is embedding these reasoning questions as you go. Yeah. Because then what the children can do when it comes to that reasoning question is they think back to when they explain to their teacher or they explain to their partner, and the power of talk and the power of reasoning whilst doing fluency means they can now access that question. They are all interlinked. It is not a separate thing. You should not be just getting kids just to practice maths. Let's do some reasoning. No. It's embedded in the very moment of learning the process. You can have reasoning going on all of the time.
Exactly.
And the best teachers do that. And that's where I think it's absolutely right that we have these different aims in the curriculum, but I just hoping to get through to people that you don't have to isolate them. And if you do, I think it's at the detriment of your maths teaching. So thinking about the last one, problem solving, I'm going to start off by saying, to me, I said about earlier how fluency is maths, right? Yeah. I'm going to say, some people might think I'm being hypocritical here or contradicting myself. Problem solving is maths.
Hypocrite.
Actually, because I think, to me, if you think about why we teach fluency, right? It's not for fun. I personally used to love adding up numbers when I was younger because I just liked the patterns. And I enjoyed that.
It feels good. Get it right or wrong.
It felt good and it's right or wrong, and I quite liked that. Okay, and you could say, oh, that's fluency. No. The point of being fluent and the point of reasoning is to apply this and have a bridge to problem solving. Yeah. What is maths if not a way to understand and solve problems in the real world? That is literally it. I've got to catch that bus so that I get to my meeting at this time. The bus takes this long. It's only every 15 minutes. What time do I have to leave my home? That's problem solving. Yeah. I've got this much budget for the month. I spend this much on my outgoings that I can't get rid of. There's a grey area of ones that I can. What can I get rid of and then be below and have enough money to pay my water bill?
Yeah.
This is maths. This is what I think school should be gearing towards. I think there is a place for logical thinking that maybe we're not going to use this in our real life. So why are we doing that? Because it's a process of problem solving.
Yeah.
The idea of your brain solving a problem and being logical is a transferable skill. And even within this moment, you might argue we'll never use this again, but you definitely will use the process of understanding how to solve this problem. That's what problem solving is for me. And it has to be a mixture of them. And problem solving, let's define it. And I completely agree with what I read about this, which was it's easier sometimes to say what problem solving isn't. So we've got this here. So problem solving is not necessarily just about answering word problems in maths. If a child already has an available method to solve a problem, problem solving has not occurred. Problem solving in maths is finding a way to apply knowledge, for children who are fluent, by the way, and skills you have learned to answer unfamiliar types of questions.
That's the main bit, isn't it? That's the biggest bit. I want everyone to focus on unfamiliar questions. It's not technically problem solving if it's not a unique situation for you to be solving this problem. The question, if we're thinking about questions with children, the questions that they're being shown should be unfamiliar to them. If you've modeled on the board a particular problem, and then what you've done is you've changed the numbers and you've given them the same problem 5 more times on a worksheet and said, have a go. A bit like sometimes what word problems do. It'll be the same method, but just different contexts in the word problems. And you're saying this is the problem solving part of the lesson. It's not. It's not problem solving at all, because you've solved the problem for them on the board, which is what do I do?
Right.
How do I get from A to B? How do I get from not knowing what to do to knowing the method that solves it? And then you're just giving them more arithmetic practice at that point, because they know what to do, because you've solved the problem for them. So yeah, problem solving is I'd say is the most like people get it wrong the most. I think I've spoken over my career. I've spoken to teachers about maths, and problem solving is the one where I find myself being that guy that corrects people the most about it, because they're like, oh yeah, I've done some
problem solving Friday.
I've done problem solving Friday. We do it every week. What I'll do is I'll have maybe 5 different problems. I'll model just one of each one on the board for them, and then they crack on. So that's not problem solving.
Yeah,
problem solving needs to be unique. It's fundamentally part of what it is.
Yeah,
and you can't problem solve unless you're fluent in the maths that underpins it.
I'm just going to add to what you said there, because it's so interesting. I completely agree with what you're saying about problem solving. It has to be new, has to be unique, but realistically, there are points, certainly in problem-solving lessons, where things can't be completely unique all of the time, right?
Mm-hmm.
If you are literally doing a small step on addition and subtraction, the kids may it's going to be addition,
That's
right?
True. They know what the
this is what I mean.
Yeah,
I don't necessarily think that in those situations problem-solving can't happen. I think it's harder. And I think there's still a place for modeling the steps and the process of problem solving. So we talk about there, like, well, if you're at the front of the board and you model how to answer this question, the kids go away and do it, it's not problem solving.
Yeah.
I slightly push back at that a little bit in terms of, I think the way you model it with everyone involved, asking questions, reasoning, getting the kids to explain themselves, thinking why we might try this method or we might try that method, that is vital in teaching problem solving. I agree. So I think there is a huge place for that. And you can absolutely say, even though my children didn't get 5 unique questions they'd never seen before, therefore they didn't problem solve, I'd be saying, no. Because I think really good problem solving teaching comes from really good modeling of what problem solving is, involving your class in that, and then letting them have a go. And it might be that you model them halfway there and you say, right, what do you think the last thing might be? Then that's definitely problem solving.
Yeah.
But they don't necessarily have to do everything from the start all of the time off the cuff for it to be good problem solving.
I completely agree. And I hope that I don't even think that's a contradiction at all, by the way. I think that's just an extra point.
Yeah.
And the easiest analogy I can make is honesty to writing. Think of modeling writing. It's exactly the same. When you model writing to children, when you expect children to do writing, by the way, you don't just say, off you go then.
Yeah.
Modeling writing is essential to them becoming good at writing. But when you model that first paragraph or those first few sentences on the board, and they're all copying those sentences or doing extremely similar sentences in their book because you've heavily modeled it, you don't count that but as independent writing. But the rest of it, you've shown them some skills that they can transfer now. And then when they're applying it to unique situations, which is the rest of their writing, or in math situation, it might just be other problems now that are equally, it's all within addition, subtraction. They know they're going to probably be doing some adding and subtracting.
But they've got to work out what to do.
But the problems are still unique. They don't know how much they're adding, how many times they're adding, whether they're subtracting, whether there's going to be,
and context can be important. Different words, different language.
Exactly, right?
Less than, sold.
Yeah.
They all mean subtract, but this is still different problem solving because you're still accessing what words might mean because you're fluent.
Exactly, right? So I absolutely fundamentally agree. You should still be modeling to children how to solve different types of problems, but also giving them a chance to independently solve new, unique problems, even if you know that it's using the same problem-solving skills, but they're still unique problems for them.
Yeah, we're gonna talk in a second, I think, more about what that can look like if you're worried that your kids aren't fluent yet. We're going to talk about that maybe when we do some scaffolding.
Sure.
But I really want to push on because I think it's something that our listeners who maybe don't quite understand problem solving completely in this way can really grasp onto, and it's your comparison with independent writing. I think that is such a good comparison because for a couple of reasons. First reason I think about what's the hardest thing for children to do in school, in primary school, because fundamentally adding 2-digit numbers together is quite easy.
Yeah.
And we can show that in 5 to 10 minutes and children can practice it. And they might not get it straight away, but
most arithmetic is fairly straightforward.
Exactly that. And if I think what's the hardest thing kids do in school, it's solving problems in maths and it's doing independent writing.
Yeah.
And I think we are so much further along on independent writing in terms of it being more understood that, of course, I'm not going to get my kids to write 2 paragraphs of writing if they can't even do a sentence. Of course, I'm not going to ask my children to apply what a fronted adverbial writing in their work if I don't already know they can do it and I've not introduced that idea of adding information to them. In independent writing, it's so common that you're like, of course I'm going to model.
Yeah.
How can I possibly expect the children to have some really good independent writing if I, as the expert, has not modeled to them what it looks like? This is what problem solving is. You don't just, in your English lessons, just say, oh, by the way, kids, we're just going to do a bit of independent writing now, where you need to work out what to do here, and I'm going to be judging you based on whether you put some independent clauses in here or not, or I'm going to be looking for this type of determiner. No, it's very structured. You as the teacher are leading them there, and you let them have a go. And if they get it wrong, it doesn't matter. We're going to do it again. If they get it wrong, it doesn't matter. We're going to do it again.
And you've put in opportunities to become fluent in those fundamental writing strategies first.
Exactly.
Like you've done a lesson, you've done lessons on determiners and whatever you said, fronted adverbials.
Yeah.
That because you're thinking, right, they're fluent in these now hopefully they can apply it to this problem solving. I mean, independent writing situation. It's so true, isn't it? How English, I think, does understand the process a bit more of fluency to the end goal, which is independent writing, more than maths understands fluency to the end goal, which is problem solving. I think they're a bit more confused in maths.
It can be. I think they can be. I think it's easier to understand. I still think schools don't always get it right with independent writing because I do think sometimes it can be a tag on, a bit like problem solving is. So we do a few weeks of learning and then we do an independent write every 3 weeks.
Yeah.
I think both of them have to be interweaved a lot more. And let's move on to now something you said there, which I thought was fascinating about when to problem solve.
Yeah.
Because I think we can speak now about, we've got these 3 pillars. And it very much felt like at the start of my career when this was first being introduced, because fluency and problem solving, this idea of mastery and everyone doing, like, really pushing themselves. I want to start by saying I think it's vital every child problem solves.
Yeah.
Every child reasons and every child becomes fluent in maths. I think that's vital. But if we're thinking about, of these 3 pillars, I don't think it should look like a 33% split.
Absolutely
in
not.
your lesson. And I think that's bad practice. And dive into that and then we'll talk about what good problem solving might look like.
Well, I even say that in that split analogy, whatever the split is that you think is optimal for your class, even that doesn't work on the individual level. Different children have different splits, genuinely, because different children some children require a lot more time at the fluency stage to become fluent. And if we accept the idea, this flow diagram of when you're fluent in something, you can then start applying it to problem solving, then by definition, obviously some children it takes them longer to become fluent in something. So by definition, they're getting problem solving opportunities at different points on that objective. But there's another layer to this, because it doesn't mean, which is the point you're getting at, it doesn't mean then that those kids that take a lot longer to become fluent, you can't just say, oh, we've run out of time again and no problem. They never get any problem solving because we never get that fluency finished.
Yeah, and Dylan Hayden on the podcast said I can't just give them problem solving because they're not fluent yet.
But they're just not getting there ever with the fluency. It's not true.
How do we solve that?
What you can do is you can give them problem solving opportunities with objectives that are not necessarily the exact unit you're doing right now at the exact level. It could be something from before. Find something they are fluent on. I've seen examples where children are just maybe significantly behind their age expected standard in maths. It doesn't mean they can't do any problem solving. It just means you might need to drop back a year group or even 2-year groups and find something they are fluent in and provide them problems that allow them to utilize that fluency. So everyone gets a chance to problem solve. It just might not be at the same level or the same level of fluency underpinning that problem solving.
Mm-hmm.
So you've got to find the balance. It sounds almost slightly contradictory. I get it, because I'm in one breath I'm saying keep going with the fluency until they're definitely fluent, because then you can problem solve on it. But I'm also saying, but do also build in opportunities to problem solve.
100%.
So there's got to be some times where you think, okay, we've done a lot of fluency, but I am going to now build in, I'm going to dedicate some time to do a little bit of problem solving, because I want them to be, I can't not do problem solving at all ever.
Yeah.
So I need to build in some time. And what that ends up transcending to sometimes in a lot of schools, we've seen this over our whole career, is people then go to the final version of this and they go, okay, cool. So we'll put a policy in place where everyone does a bit of fluency in their lesson, and then they do a bit of reasoning and a bit of problem solving. If we do that in every lesson, don't worry, teachers, I know that children learn at different paces, so I'll let you do different amounts of them, but everyone has to have fluency, reasoning, and problem solving in their lesson. Teacher A, you can do 50% fluency, 50% reasoning, problem solving. Teacher B, you got class find it a bit trickier. You can do 60% fluency and then just 40% reasoning, problem solving, but everyone's got to do it.
Yeah.
It doesn't work.
No, I think this is, hopefully, if we're really establishing these definitions at the start, it just becomes common sense that this can't happen, and it doesn't have to happen. And I remember as we were preparing for Ofsted as maths leads, Ofsted came in, we had a very successful maths Ofsted, and we get very successful data in maths in all the schools that we've ran, so we know this works. And we were looking up things, and it said like it can actually be seen as bad practice for problem solving to be shoehorned into every single lesson, because if you're doing that, you're not doing problem solving for the right reasons. You're doing it for coverage because you're worried it needs to be seen.
Yeah.
Problem solving can happen twice a week. Problem solving can be a whole lesson. It can be half a lesson once a week. It can be every day. It can be. It's not a hard and fast rule. And if you're thinking about what problem solving has to look like and what fluency looks like and what we might see as like a generic split, I think for me, the vast majority of your maths teaching should be around fluency. You have to get that right. You have to. It's as simple as that. You have to teach the curriculum. You have to get through things, and children need to be able to do maths. And if we're thinking about reasoning as being able to understand concepts, procedures, and language, that is by far, if you just think about it for a second, you can't do the rest unless you have that. So the vast majority of your time and your lessons should be on fluency. The reasoning happens all the time.
Yeah.
I honestly wouldn't even be saying to someone, oh, you need to have a reasoning chunk in your lesson. It would just be so built into my planning, to my questioning,
to your fluency,
to my fluency, and to my teaching. That fluency is happening all the time in whether that reasoning is happening all the time whether I'm doing fluency or problem solving. Reasoning is thinking, like it doesn't even need to be a separate thing. And then I could either think to myself, okay, my children aren't quite fluent in this, I'm going to carry on. You might think, oh, my children are getting fluent in this, but there's something else I want to recap and do and keep them fluent in that. And you might even think to yourself, I think it's time for some problem solving. And that might be, my kids are fluent in this year 4 stuff I'm doing. Oh, rub my hands together. Let's try a problem where I know the cognitive load won't be on the processes and the understanding.
So you're going to do it at year 4 level.
So I'm going to do it at year 4 level. However, I might well have a class or even a group of children where I think, do you know what? You guys are fluent in year 4. You're going to do it at this year 4 level. You guys aren't, but there's no way I can deprive you of problem solving because that's what maths is.
Yeah.
It's literally an aim in the curriculum.
Yeah.
Let's just dip back a little bit. But the art of problem solving, the ability to look at and try and use your reasoning to know what to do, the techniques involved, the types of question, whether it's missing number, word problem, finding all possibilities, trial and improvement, whatever the strategies might be, everyone can use those strategies. Everyone in any class can do trial and improvement. It might be that one's in the context of something much more simple for them to understand. It might be another one is much trickier to know that's what you've got to do. But part of the problem solving is figuring out you've got to do that and then doing it.
Yeah.
But you can fundamentally have any amount of children with any level doing problem solving in maths. And it's vital. And it doesn't have to be shoehorned in. It doesn't have to be the same amount of time every day. It just needs to be a whole picture. And I think that's where you can fall into that trap of tick box, because I want to just see that everyone's doing the right thing. I want to make sure it's all right.
Yeah.
You've got to be holistic, because actually tick boxes by definition can force you to do it wrong.
Exactly. What happens a lot in that situation, just to be extremely clear, is when you are doing the tick box situation, you are then in a position possibly where you're showing kids problem solving opportunities, and they're simply just not fluent in the maths yet, and therefore it's just a complete waste of time, because what you end up doing is you end up modeling it all on the board, taking away the problem solving element, and end up inadvertently doing more fluency, which probably realistically is not the worst thing in the world, because they clearly need more of that. But it would have been maybe more effective to have just been carrying on with the way you were doing fluency.
A really good idea, very quickly, on problem solving, because I love this as like a function, is to take the numbers out of the question, because sometimes by taking numbers out of the question, you're kind of getting rid of that difference there of like, oh, are you working at a year 2 level, year 4 level, year 5 level of addition, let's say. Because no, what that then becomes is then the children are simply solving the problem, and the question is simply just, what do I have to do here?
Exactly.
What is the like, what do these words mean? Are you fluent in the vocabulary we've learned? Oh, you are. Brilliant. That means you've been exposed to a bunch of vocabulary. What do you think it might mean for a delivery to be shipped somewhere? That is not the word add. No. That is not the symbol add. That is you really think to yourself, okay, I can use I become fluent in this. I understand what these words mean. I think we need to add. We don't even have the number. But the act of that, and that this can be reasoning and problem solving. This is where it overlaps. You can explain to yourself, I think it means add because the shop would have more of it.
Yeah.
Oh, interesting. What does the question say at the end? The question says, how much does the shop have at the end of the week? Oh, interesting. So is there something else in the question that might happen in the week?
This is like as close as it gets to actually extracting pure like problem solving and reasoning, because you're almost like taking out the bit where they actually do the maths at this point. You're taking out the numbers. I actually learned that hilariously, if we're bigging up people like Gina Donaldson. I actually learned that from originally, right at the beginning of my career, Gareth Metcalf, who we had on this podcast 2 years ago now. It's crazy to think that. One of our earlier episodes, go and find it. He's an unbelievably talented mathematics teacher. He creates incredible resources like IC Reasoning, IC problem solving as well. Really, really good. But I first picked that up from him. I went to one of his training many years ago. I was like, oh my God, yeah. It's just another string to your bow, isn't it? There's so many little things and tools and tricks and ways you can expose children to isolated skills, as well as just opportunities to just straight up problem solve, as well as opportunities to just practice a method in arithmetic, as well as opportunities for them to become fluent by showing them 5 different ways of looking at an arithmetic question that's just ever so slightly different. There's a bit of very fluency in there where they're using slight elements of reasoning, but it's not problem solving, because ultimately it's just 2 numbers and you're either adding or subtracting them or multiplying and dividing them. You've got all these little levels, and I just think you have to genuinely, to be a really good maths teacher, I think you just have to be aware of all of these layers and elements, and aware of the differences between reasoning, problem solving, and fluency, and how they are, like you said, they are both pillars in terms of the way we account for them, and they're 3 separate aims, but they're also not pillars in the idea that they're completely separate things
all of the time.
That they flow through each other. Reasoning flows through fluency and problem solving, and just having this grand awareness of all these things in maths is what makes you a really good maths teacher. And I think without these things, what can sometimes happen is, it's the classic, what I think a lot of people say, that when I was at school, this is what we did. We got rote taught a method that works. When I see this number times this number written like that, this is the method that works. Just do that. Why are we bothering teaching kids different methods? It's like, well, we're teaching kids different methods because when the problem isn't shown exactly like that, they then don't know what to do, because they were never really taught to think about it. They were just taught, if you see this, do it. You could teach a computer to do that. If you see this, apply this method. It doesn't always work.
And to just jump on that and finish off, that's still important to do.
Exactly.
It's still important. We're not even these people who are saying, why don't you just do that? It's like, mate, I do. That's what fluency in arithmetic is. That's really, really important. You're not wrong. You are not wrong. That is really important. But you know what I'm also going to do? Just expose them to different ways.
Show them a different way. Exactly. It's the most simple one I always think of, right? And this is something we're building into our bit of software for maths that we're passionately building right now, which is really, really focused at the moment on arithmetic, and it will expand wider into fluency and more. One of the easiest things that we've done is, can you move the equal sign to the other side? Because I can tell you in my career how many times, where, especially earlier on where I maybe didn't consider this, I'd show every single question as A times B equals, or A plus B equals. And it'd always be arithmetic and then equals at the end. And the kids genuinely thought equals meant this is the answer. They thought it meant the symbol where you put your answer next to it. And they didn't really understand what equals actually meant. And as soon as you then took the exact same question, A times B equals, and you put blank equals A times B, they were like, oh, oh my God, what do I do? Have I got to use inverse? Because they don't know. They haven't been exposed to the variety of fluency enough. They know the method, and I will practice that method. I'll make sure they are fluent in the method itself, but I'll also make sure they're fluent in a wider sense in, this is some different ways to even represent this arithmetic. You know, like,
precisely.
And that is just fundamental to the way we're building this
Yeah.
this app, this software that we're building is like, it's not just methods, even though that's unbelievably important. It's also, here's some different ways you might see the same arithmetic question, but still applying the same method. And it's important. Kids are exposed to it, by the way. So yeah, use this.
And the great thing is with this and fluency in general, I think that the really important thing about knowing facts, for example, and becoming fluent at something is you are doing it quite frequently as well.
Yes.
You're doing it quite frequently, not necessarily for ages and ages in terms of, obviously you need to teach a lesson and have varied fluency in there. But then when like I've taught addition and subtraction, and this kind of links in to be fair with schemes and stuff in general, which is, it's very common now to block things. Maybe we can talk about that a little bit, where you might block your learning. And what we mean by blocks is there are essentially two ways traditionally that you might teach maths. One is a spiral curriculum and one is a block curriculum. In a spiral curriculum, let's take addition and subtraction. Let's say you've got 6 weeks of that you need to do in year 4.
Yeah.
In a spiral curriculum, you do it for 2 weeks before Christmas. You do it for 2 weeks before Easter, and then you do it for 2 weeks before summer. And the idea being you come back and maybe get deeper each time. The block curriculum would be you do all 6 weeks before Christmas in a row because you're really diving deep into it and getting those opportunities where for the first week and a half, I didn't really get a chance to problem solve too much.
Yeah.
But my goodness me, because I'm doing it for 6 weeks, we're going to dive in. They're going to become really fluent and get those opportunities. I think block curriculum really lends itself to be able to apply what we've talked about today better. Yeah. I think it's a good thing.
Truly mastering maths.
To truly master it. I do think it has a massive drawback, which again goes against one thing we've said, which is fluency needs to be done all the time. You need to be revisiting it all the time. And that's where a block curriculum loses its power if you don't do something about it. Because then those children doing 6 weeks of addition and subtraction might get really deep, and by November they are unbelievable, but they're not going to do addition and subtraction until next November when they come back to it for the next year group. So maybe you could talk a little bit about this. It's like, why is it still important, even though maybe we have this idea of mastery, to become fluent in something? And thinking about our platform, even about arithmetic testing every week and becoming really good at doing maths. How can we square that with what schemes do now, which is block stuff?
Sure. So there's something really important that we need to understand about block curriculums, which is they are mapping coverage of your main lesson objective. And I think sometimes it's easy to forget that might not be the be all and end all of the entirety of your maths lesson. A really good maths lesson, and this is, in my opinion, is the best practice, is that there is a significant chunk of the allocated time that you have to teach maths that is dedicated to your lesson objective. And that might very much be following your curriculum map, your block curriculum. But there should be another significant part of your lesson, maybe smaller than the main bit, which is dedicated to not that main lesson objective, but other things. So mostly fluency. It could even be problem solving. We'll come to that later. But a part of your lesson that's dedicated to recapping parts of fluency that you've looked at in the past, so that you're not leaving at a year. We should never be in a situation where you're actually leaving an objective an entire year before it's remotely talked about or touched on again. That is bad practice. And I hate the idea that anyone looks at block curriculum and says, well, that encourages this, therefore it's bad. It doesn't actually encourage it. It's really just mapping out your main lesson objectives. You should be building, as a school, you should be building in time. I think, what did we have, about 20 to 25 minutes? We had this dedicated section, which is nothing to do with the main lesson objective. It could be linked if you want it to be. Yeah. It can be linked. It could be we're pre-teaching a skill that we think that's going to be useful. And by pre-teaching, I'm literally talking about, let's say you're doing rounding and you always say the same example. It's the easiest one to think of because it's so like tangible. Yeah. When you're teaching rounding, like obviously you need kids to know multiples of 10, or if you're rounding to the nearest 10, they intrinsically need to know what multiples of 10 are when you're teaching rounding. So you might be doing a bit of pre-teaching in starters leading up to this rounding unit where you're reminding them of multiples of 10 if you feel that's what they need. That's what I'd call as pre-teaching. And you've also got reteaching in that time. It could be that, you know what, we finished this unit on addition subtraction. We use that example a lot. And a month later, I just wasn't satisfied fully that they were as fluent as I'd like them to be. And you know what? I'm going to use some of this time outside of my main lesson objective in later blocks across the year to reteach some smaller parts of those small steps, those elements of those lessons. I'm going to reteach. And the big one, the thing we do the most is just genuinely just recapping. It's been a bit of time. I want to make sure I'm covering and going over and making sure, because fluency has to be done all the time and they're building on it. I'm going to go back to old objectives and I'm going to recap this.
What's the difference to reteach?
Reteach is, I guess, is from mindset, right? So reteaching is specifically, I feel like they weren't fluent.
They weren't there.
They weren't quite there, right. and I want to make sure I'm getting them to a certain standard. Yep. Recapping, they could be absolutely there, But it's very important that it's still refreshing that mind.
In that recap, obviously you're saying that they're still fluent. Do you think in this like chunk, because I used it a lot to be like, cool, well, I can reason and problem solve now as well.
Yeah.
Would that come into recapping for you, or like going over stuff again?
It would do, yeah. So for me, that is down to, all honesty, like the makeup of your class as well. So I've had classes before where genuinely, because we were struggling with the fluency so much, and I was building in problem solving opportunities in the class, but fluency was a much bigger issue than maybe other times. That time for me became almost exclusively more time to recap and reteach and pre-teach fluency things, and very, very rarely. Whereas I've had other classes where, because they're so fluent, it doesn't take me long to recap things to make sure they're still up there. It's like bouncing off the limiter of like, they're right up there, really, really understanding, really super fluent. So I'd be like, cool, I've got some opportunities here to now recap or reteach some opportunities for them to problem solve as well, because that is the end goal, and I can make that infinitely hard. You can't complete problem solving. It just goes on forever. So lots of different things you can do, but my main point here, maybe you can dive into it more, is you've got your main lesson objective and you've got your coverage, and as part of your lesson you've got exclusively a special part of your lesson that is designed for recapping, reteaching, pre-teaching, doing whatever else you need to do. I think it's vital. I think it's the way to make schemes work like this. I don't think they work otherwise, and I think I'm going to slightly change what you said. I don't think it necessarily has to be part of your lesson. I quite like thinking of them as literally separate things. I can think of my maths lesson where I'm going through the curriculum that has the majority of that is fluency, and it has to be because I'm teaching them how to do the maths. I've had people message us saying, I'm really frustrated. My head teacher says every single lesson needs to have this much reasoning and this much problem solving. It's annoying me. I'm like, I get why that's annoying, because it would annoy me. Because when I'm teaching the curriculum, I have to teach you how to do the thing. And part of that is going to be reasoning and problem solving. Reasoning comes for everything. Part of it will be problem solving. But the majority of my lesson is fluency, because I'm teaching you how to do the maths. This separate thing here, the reason I love it so much, and I thought it was the best thing we ever did for maths in our school, was introducing this as a hard separate thing. Protected time.
It's protected time. It is literally protected time, where you get 20 to 25 minutes. And I used it for times tables because I was in year 4. Big focus on times tables. I did a lot of times tables in there. I did a lot of recapping stuff. If I finished my block and I was like, I had a set that maybe needed more support in maths, let's say, and I finished my block and I thought, do you know what? Okay, I might sometimes choose to just do it for another week or 2. And that's also fine. You've got to be flexible. But I might think, no, I really just need to move on, actually. So I'm going to move on. Lots of them got it, but some of them didn't. Then I'd use that time to go over that, become more fluent.
Reteach some bits.
Literally. I would use a lot of that time to do some problem solving, because I found myself with my class who needed more fluency. I really started to resent the fact that I felt like I wasn't doing enough problem solving with them in those lessons. So I thought, I'm going to make sure I do this in this time.
So you nail the fluency in the lesson.
I nail it. Yeah, because I'm reacting to the kids. Like there might be some lessons, like you said, where I'm doing it all the time in my lessons because the kids are fluent. My kids weren't quite fluent. So I thought, what I can do in my extra time? I'm going through the curriculum with them and I need to do that. But in this time, I absolutely went on to the year 2 curriculum, downloaded PowerPoints of reasoning problem solving questions that based on what they're called. And I went, Yeah, my kids absolutely can count in 2s. Like they can do that. That's fine. They're struggling a bit with the year 4 objectives, but they can count in 2s. Let's look at some problem solving questions that use counting in 2s. So my kids are no longer thinking, oh God, I don't know, because I don't know how to do the maths. And
I'm already overloaded.
I might even think, I'm already thinking about these numbers are too big. I don't really understand. No, the maths itself is fine. They can put all of their effort into thinking, what do I have to do to solve this problem? And I found that chunk of time invaluable. And we had, to make it really clear to everyone, that's 20 to 25 minutes a day.
Yeah.
And a chunk of that would always be practicing known facts, because you have to know your known facts, and that's fluency. And a chunk would be reasoning, problem solving, or pre-teaching, like you just said. But what was really powerful, I found, because it's what I would have wanted, which is why we introduced it in our school, it was all power to the teacher.
Yeah.
It was not, I was not coming around and saying, have you done your 10 minutes reasoning and problem solving in this little section? Couldn't care less. I said to the professional, as the teacher, you are their teacher and you teach them 50 minutes every single day of maths. What are you not giving them enough of? What do they need more of? What do you decide? If you had another 20 minutes, what would you do with the kids?
Yeah.
Oh, that's interesting. Do that.
Yeah.
And that is your profession. And my kids made so much more progress because I could be so targeted in that time. And just flipping that a bit, people thinking, well, my maths lesson's short. So you just said your maths lesson was 50 minutes. Yeah, because I wasn't obsessed with getting through reasoning, problem solving, and doing my fluency all in one lesson. It can be shorter. It's a very small step. The curriculum can be condensed.
50 minutes is genuinely a suitable amount of time. It is. I remember thinking, oh, it's so short. I remember going for an hour to 50 minutes once, and I was like, oh my God, is it possible? How can I possibly teach maths? And it's because I was locked in that mindset of, I have to do X, Y, Z. I have to get all these elements in, otherwise it's not a good maths lesson.
Yeah.
It's just not true.
Yeah.
Just take them on the journey. The whole lesson can be fluency. And I know there's multiple years in my career where I felt like I would look terrible if someone looked at my lesson or I looked at the book afterwards and I'd only been working on fluency in that lesson. And I wish I could go back and be like, no, if that's what they needed because they were not ready and you felt like it wasn't appropriate to do problem solving in this lesson yet and you didn't want to go back to a previous year because you're like right in the middle of this little journey and you just wanted to finish off making sure they're really fluent, then that's what you need to do, and that is okay. You didn't need to do that reasoning problem solving that you planned because you got told to. Push it into a starter in another week. Maybe don't even use it, or maybe use it in tomorrow's lesson, whatever. But that was the right choice. You adapted on the spot, and they needed to become fluent. And there's one thing I will just say, I'm going to clarify this right now, because it sounds like I feel like I don't want people to think we're being a bit wishy-washy with like, yeah, you can just do everything, ever, all the time. One thing I absolutely did just nail and hammer all the time in my starters was, at the end of the day, arithmetic. Yep. I would say at minimum once per week, my extra 20-25 minutes was dedicated to recapping or reteaching, very specifically at the fluency level, some arithmetic. And that might include, I've presented it in its inverse format, or I've put the equal sign on the other side just to give them that bit of variety. But ultimately it was, I need us to repractice this method because I taught this to you a month ago. We haven't divided decimals by numbers in a while because realistically that's one of 19 objectives by year 6. Here's 5 questions, dividing decimals. Can we remember it? You've forgotten it? Cool. 20-second recap because you were fluent. You were here before you were super fluent. You've just dropped down a tiny bit. I'm just getting you back up there. Do you remember that? Oh yeah, I remember that now. Brilliant. We've practiced it for 10 minutes. Move on. So arithmetic embedded in my starters all the time.
I did it every single day in year 4, like every single day. It was not even a question. Like my kids got to the point where they're like, oh, here it is, the 5 questions again. Because I do 5 arithmetic questions every day. Yep. Some days it might just be addition. Some days it might just be addition with different digits. Because I know for a fact there's a misconception they can't line up their numbers properly. Some days it might be a mixture, where I've said, actually, you know what? We've done so much work over the last couple of weeks. Here are 5 questions with 5 different question types. It's still arithmetic, but now you're showing me your fluency and your reasoning because you need to work out what to do each time. It's not just doing the process, not reading it, understanding the symbols. It's still a part of reasoning. It's still fluency, but it's that really important skill that children need to be able to do maths quickly and accurately. They have to be fluent. And arithmetic is the perfect example of that. You have to be accurate. And I'd say it to my children, and I'd be saying it in a way where like it's a really nice supportive thing, where I'd say to them, I know for a fact when we finish year 4, every single person in this room will be able to, I say will be able to answer every single question on your arithmetic paper.
Yeah.
You might make a mistake. That's fine. You might get there and rush through something or miss an exchange. That's okay. But I know through my coverage and my daily practice and my fluency that I know everyone in the room can answer that question.
Yeah.
And that's all I want to get to, guys. And then we'd be doing arithmetic at the end of the year. It's out of 40, and my class would be averaging 35. And there'd be the odd mistake, but there wouldn't be anything that a child goes, yeah, I've never seen that before, because I do it every day.
Or I can't remember it at all.
Exactly. And that's where this idea of our maths platform has kind of come from. It's like, okay, how can we make it easy for teachers to do this? Because I know the power of doing arithmetic every single day and getting fluent in being able to actually do the maths. But a teacher might not quite get the nuances of the different questions. They might not quite understand maybe why there's 2 exchanging in this question, or going past it, bridging past the 0 makes it harder, etc. And even if there are teachers who get that, it can be time consuming and frustrating to make sure you've got coverage. And it can be time consuming and annoying to get every individual child's data and be like, well, that child can't do this, this, and this. This child can't do that and that, but it's a different one as well they can't do.
Yeah.
Our platform's going to be something where you can really easily harvest this information from the children. They can practice it. They can do it every day. They get what they need. It's adaptive to them. And it's going to be so powerful to get children better at arithmetic. And it's something they don't have to do for an hour a day. They can do it for 10 minutes. They can do a test. They can do a bit of practice on what they need. And the teachers can go in and say, actually, I want this, and this question. Generate me 10. Done.
Yeah.
It's going to be so...
Oh, man, I'm excited.
so gassed about it, because anyone listening to this who kind of gets what we're saying here about arithmetic, a lot of people have already messaged about it. message us and just let us know if it's something that would interest you, because it's going to be so powerful. And the reason we're doing it is not because we're saying teach to a test.
Yeah.
You just got to be able to do arithmetic, Hayden. I'm hoping through what we've said today, you can really understand that unless you've nailed that, the true goal is pointless.
Yeah. You can't build on top of broken foundations. You need to have the foundations in place. We are trying to target the thing that matters the most, which is the foundation. And we know one of the side effects of maths mastery is the misconception of having to do, we just need to put in loads more reasoning and problem solving. And the horrible side effect of that is, in some places, in some schools, in some classrooms, arithmetic and fluency is actually getting a little bit weaker because where they would have been doing way more of that before, they're now not doing as much because they think they have to. I've got to do reasoning and problem solving every lesson. And now they're not as fluent. And it's like, oh man, we need it. We're trying to tackle the problem from every angle.
Yeah. I had a conversation with someone the other day who said they're in year 6, they messaged us and they said our school is thinking of starting to do arithmetic every week. And I was like, sorry, what?
Surely they were doing it.
Excuse me. And it's like people go so far down this road of schemes. And I suppose I just wanted to get your quick thought on schemes, because I am not anti-scheme. I think schemes are really good. However, when implemented really robustly and strictly and stringently and badly, they can be awful. And I think this is a symptom of this, where schools might buy in schemes or say, yeah, we've got this. It's rooted in evidence. It's a good scheme and it has lots of chances for fluency and reasoning and problem solving, all that kind of stuff. But maybe it's missing just enough to just practice and become really fluent in actually doing the maths. And then a school doesn't do it.
Yeah.
Because they're so wedded to the scheme. So very quickly, if you could just summarize our thoughts on schemes, because I know we're on the same page here. Is that a reason to bin schemes, or do you just think, look, come on?
Absolutely not. I'm going to say what I said earlier. Schemes are really good for mapping coverage of lesson objectives that you're teaching the main bit of your lesson. Schemes are very good at that. What I feel like schemes lack a lot of, and which is another reason we're doing this, is because we feel like it's not there. What schemes aren't so good at is taking something like just arithmetic and providing loads of resources and loads of fluency tools and ways for you to just practice that bit, and saying like, oh, hey, in your 20-minute segment that you do in the afternoon, or in your 20-minute segment that you do at the beginning of your lesson, however your school allocates this bit of extra time that we're talking about, like Dylan said earlier, it doesn't need to be within your maths lesson. It could be another part of the day. Here's the resources and map for that, and this is some great stuff. It doesn't exist, I don't think, not to a level that I think is good enough. Which is why we are building this arithmetic tool that is going to be. I get too excited. I have to calm myself down. But I genuinely think it's going to be transformational, because I think if you get those foundations right with a really, really good adaptive tool that works at the exact nuances of math. You gave an example. When you've got a tool that knows the difference between a 4-digit number and a 3-digit number,
with exchange or without exchange,
without exchange, and the different and all of the combinations of that, and understands those nuances. And if I want more of these questions, it's like, yeah, you can have more of these questions because that's what you want to practice. Like you said in your starter, you might practice one day a very specific misconception that your kids are making, and give them 5 more of those.
A misconception which literally couldn't be taught if you just did random numbers.
Exactly.
Because if you're doing random numbers, you might not get exchanging, you might not get the same number of digits, etc. You're so right, and this is where it's going to be transformative, because you can create 100 questions regenerating the same thing. And do you know why I think it's going to be such a good tool? Because it puts together 2 things that we're really passionate about. One is quality maths teaching. And whether you are adept to it or not, I'm not judging you as an individual, because some people are much more adept, like we know it inside out. Other people won't, and that's fine. Their passion might be English, but they've got to teach maths and they're really good at teaching maths. Whether or not you're really, really like clued on, this can do it for you. And what it does is then allows you to teach. This isn't going to be the thing that like suddenly just takes over your class and teaches children how to do it more than you. No, what this is going to do is give you the tools to be able to teach it so well, and save you time, and give you exact things that the children need, and do gap analysis for you, and give them targeted intervention. It's going to do that. And then you as the teacher can go around and say, right, you're struggling with this. 5 minutes with a whiteboard, let's go. And you can teach them it. It's so powerful.
Can I finish, because now we're getting super excited. Can I finish by telling that there's a moment that I can think of where I was like, oh, this tool just doesn't exist. This doesn't exist and I need it. Which was, it was a SATs question that I was looking at. I can't remember the exact one, but it was something along the lines of like 2.5 lots of 57.
Yeah.
It was a really horrible, it was like the last question in a SATs paper once. And I was like, that's rancid in terms of giving the kids that. And I wanted to have more. I was like, I want to practice these questions because that's actually really hard. I've got a high math set. I want to practice mixed numbers times like really horrible numbers where you can't even divide by the denominator. Like 57 doesn't divide by 2 without going to decimals.
Yeah.
It's horrible. And when I used a random number generator to just like generate more, they didn't get the nuance.
Yeah.
It gave me stuff like 2.5 lots of 20, and I was like, no, this isn't what I want.
Yeah.
I want it to understand why this is hard.
Yeah.
So we're building a tool that does that.
Exactly.
And that's it. That's it for me. I was like, that needs to exist. That needs to exist, and it needs to get every single level of nuance on every question and be able to just give me 10 more like that.
Yeah.
You know. Anyways,
yeah.
but
you're right. You're right. And I think it's built in. Hopefully, again, from this whole episode, you get how much we love maths. We are obsessed with maths.
Yeah.
We get good results for our children. It's what our passion is, and the ability to have been building this makes me so happy because I'm not building this and then, oh yeah, it's important because I've built this thing. No, I believe everything I've said in this whole episode.
Yeah.
And that's why I think this is such a thing that I've thought for years would be so powerful and good to build. And it's happening. Yeah, it's going to be so useful.
Watch this space,
teachers,
guys.
honestly.
But yeah, keep asking us because every time you ask us questions about it, we get really giddy and excited and want to talk about it.
I'm so excited. We're going to wrap it up, but there's just one last thing I wanted to mention. And I don't think we need to go into detail about it because we've gone into so much detail already. But I think part of the problem, if we're going back full circle, is obviously preparing for the test, right?
Yeah.
So thinking about SATs at the end, and we're thinking, oh, well, yeah, you're just creating a thing that helps you prepare for the SATs. Yeah, it does. It does help you prepare for the SATs. It also makes kids better at maths. Like the Venn diagram can overlap, right?
Yeah.
Just because you're preparing for the test doesn't necessarily mean everything you're doing is bad for the kids.
Yeah.
Fundamentally, knowing how to do maths and practicing it and getting quicker and more accurate makes you a better mathematician. Does it also mean you're going to boost your arithmetic scores in your SATs? Yeah, it does. Yeah. And that's good as well.
Because you're better at maths.
Because you're better at maths. Not because you're just knowing how to get around a test or fudge your way through. No, you can do maths more quickly and more accurately.
Yeah.
And one thing I was going to put over to you about the SATs, you're in year 6 for a long time. I've never liked the naming of the SATs. Sounds ridiculous. There's a arithmetic paper and a reasoning paper.
Yeah.
And I'm like, oh, what? Like, okay, there are reasoning questions, I suppose, like explain this in the thought bubble.
Mm-hmm.
Of course, that's a reasoning question. Fine. But the reasoning paper has fluency in it.
Yep.
It's not reasoning. It has just straight up fluency questions like order these numbers.
Mm-hmm.
Like it just has like how many sides does a square have kind of thing. Like it has those kind of fluency questions. It has some reasoning and it's filled with problem solving as well.
It has always annoyed me because I feel like it contributes to the problem of like people getting confused between fluency reading and problem solving. Because realistically, what's happening is, you kind of summarized it. The two papers, it feels like it's supposed to say we have a fluency paper and then we have a reasoning and problem solving paper. I feel like that's how people interpret that when they see arithmetic and reasoning. They're like, okay, that's the split they make in their mind. But really, the split is, we have this really a subset of fluency, which is arithmetic as one paper, and then we have all of the rest of fluency.
Yeah.
All of problem solving and all of reasoning that comes in between that, because reasoning is just everything.
Because I think there's some reasoning in arithmetic. Some people might tell me I'm wrong here.
Well, it is the example I gave earlier.
Exactly, like the idea of in arithmetic, being fluent includes the ability to know which method to go for and why, etc.
Yeah.
But that is reasoning. Like it inherently is the thought process of, do you know what? I'm in this test. I've got a method here that'll take me 10 seconds or a method that'll take me a minute.
Exactly that.
Knowing to go for the 10-second one, that's reasoning. You're thinking it's true.
I've got a really good example of that, which I'll say really quickly. Long division always happens, right? If you give a child a 4-digit number divided by 45 and another question that's a 4-digit number divided by 47, a child that hasn't been taught fluency properly with varied fluency might just have one method they use that works. And do you know what? They could get it right and that's fine.
Yeah.
But the reasoning comes into play when you go, some children will look at 45 and think, I can factorize that into 2 short divisions. I can divide by 9, get an answer, divide that by 5. Making it, on the whole, a lot easier because I don't have to think about the 45 times tables and finding huge remainders.
Yeah.
That's way quicker to me. And another child, when you look at 47, they'll go, it's a prime. I can't factorize this into 2 times tables that I know. So I'm going to have to just do this my long division method. Mm-hmm. And in the first one, they've saved loads of time. And the second one, they're using the proper method.
And you telling me they haven't done reasoning?
Really? That's what I mean. Then that's in the arithmetic paper.
Yeah, exactly.
So reasoning kind of is everywhere, yet we call one of the papers reasoning.
Yeah.
I get it because it's more reasoning. Arithmetic is more stripped back.
But it's not reasoning to just be able to do a number that's adding 10. How often does that come up in the reasoning paper? It's like, what's 10 more?
What they do to make it look different though is they'll put 3 of them in one question. It'll be like this one plus 10, this one plus 10, this one plus what equals this. And it's like you have to get all 3 to get 1 mark. And it's
it's like each individual one of those questions could have been in the arithmetic paper.
Yeah.
If it was just one of them.
Yeah.
That's all I would say. It's slightly confusing. I don't think it's an issue because, like I said, I think reasoning permeates everything. Yeah. I don't think you can say, it's not reasoning, it's annoying, but I just think it just helps to push the narrative of a bit of misunderstanding.
I mean, on the upside as well, it does also just kind of reinforce the idea that arithmetic is unbelievably important, because they felt the need to put an entire paper to that part of fluency.
Yes.
And then call it, the naming we can disagree with. But yeah, ultimately arithmetic is like, it's essential. Yeah. It's an essential underpinning part of maths. And we should be looking at, can the kids do the maths? And then also looking at, can the kids apply it in any context,
Absolutely. That is probably my favourite chat I've had in a long time.
And there's so much more we could say.
I know, like we've got so many notes here. Maybe we'll do some more in the future. But guys, if you enjoyed that, please do leave us a review wherever you get it. And most importantly, honestly, for this one, just share it around a little bit, especially, if you're a newer teacher, if you're training, just send it around to people, because it is really important information to know. And if you're more experienced staff, what I would say to you is, what we've all said here, it's rooted in fact, it's rooted in research, it's what it is. So if you kind of are noticing in your school, maybe the balance is a bit off, and you as a professional kind of have this idea of like, it's not been done properly, push back a bit, like just ask about it. Just say like, look, okay, you might get shot down fine, but you might not, and you might be able to change stuff.
And also talk to us, because if there's anything else more you want us to talk about maths, we love it. So if there's elements you thought, I wonder if they're going to talk about this in this episode, and we didn't, please write in, because there's almost definitely another episode we'll do in the future where we can talk about these other elements of maths.
Well, we're going to be building our maths platform,
exactly. Every episode from next week will exclusively be about maths.
This is a maths, but it's not, don't worry.
We're going to change it.
We'll go back to moaning about toxic schools soon. Fine.
Only if they're doing maths incorrectly. See you next week.
See you guys.